In this video, I would like to show you how to measure forecast quality. There is no single number that tells you how good a forecast is. We're going to calculate multiple measures, and each different measure will tell you something different about the forecast. Okay. First, I'd like to open up some space here. I want to move this alpha out of the way. So to do that, I come on the first row. The arrow changes to a dark right arrow. I right click and I say insert. Okay, so I have inserted a row here, and then I move the alpha to this new row. Okay, and as you can see, the numbers haven't changed, and the formula still refers to this. Okay, so regardless of how I move alpha, the formula still references the right number. Anyway, so I have the forecast here. Let me say this is exponential smoothing. Okay, and it's just regression forecast. Okay, so and then this is the error related to that. And so now I have the errors. I need to calculate the absolute error, squared error, and absolute percentage error. So this is going to be absolute error. This is going to be squared error. Okay, and this is going to be absolute percentage error. Okay, so I click, make these bold also. Okay, so what is the absolute error? Absolute error simply takes the forecast error, makes it positive. If it's negative, it makes it positive. If it's positive, it stays positive. So the way I do it is I click the equals key, ABS, absolute value, open parenthesis, click here, close parenthesis, enter. Okay, and then I double click here to copy the absolute value function all the way down. Okay, so here are the absolute values of these errors. So 0 stays 0, a negative number becomes positive, a positive number stays the same. Okay, so that's what the absolute value function does. And then I calculate the squared error. So I come here, click equals, error times error. Okay, enter. And I come down here to the lower right hand side, and then I double click. Okay, so as you can see, I get humongous numbers. So let me copy this format here. Format, copy to the entire column. Now let's calculate the absolute percentage error. Okay, so what's the absolute percentage error? It is the ratio of absolute error to the actual observed demand. Okay, let's say this is the absolute error, 891, compared to the actual number of passengers, 72,334. Okay, so what I'm going to say is this will be equal to absolute error, okay, absolute error, divided by the total number of passengers observed. Okay, this is not the forecast, this is the actual, and then enter. Okay, so as you can see, I get the decimal number. An easy way to convert this to percentages here in the numbers tab, you have this percentage sign I click that, it's roughly 1%. Okay, so maybe I want a few decimal places, so I click here to increase the decimals. So 1 decimal, 2 decimals, 3 decimals, 4, 5. For me, it's two are enough, so I'm going to decrease the decimals. Okay, so this is good, 1.23%. So this means this particular forecast is off by 1.23%. Okay. Now I want to copy this, so let's copy this up. Okay. So here we're 0%. Okay. 8.31%, 22.76%, etc. And I just double click for the entire column. Okay. So I do the same thing for the regression forecasts. So I'm going to copy the headers, Control C, Control V. Okay, and then I can also copy the formulas, the cells. As I copy the cells, formulas will also move. Okay, so Control C, Control V. Okay, so let's look at these. Okay. Okay. So this one, let's click on this. So absolute is error is the absolute value of this. Okay. So positive numbers stay positive, negative numbers become positive. Now the squared error, okay, I multiply the error with itself. So I basically square the error. And here I have a problem. It says division by 0. So I click here and it highlights the cells used in the formula. So what I need is the numerator should be absolute error and the denominator should be the actual forecast. Okay, so the blue cell is yes, that's the absolute error. That's what I need. But the denominator, this green cell, refers to an empty cell, so that's why it's complaining about division by 0. So what this cell needs to be is the actual number of passengers. So so I bring the cursor so that on the edge of this cell, okay, here or here or here, doesn't matter. It turns into a four-headed arrow, and I can click and drag, okay, to here. Why? Because this is the actual number of passengers, okay, and then I click enter. So and I double click here to get the absolute percentage error for the regression forecast. So now what do I have? So here for the when I use the exponential smoothing, I was off by 0%, 8%, 22, 16, 14, etc. Here, as you look, we start with 21, 22%, 32, 1, 2, 6, etc. Okay. So what is the bottom line? Okay, the bottom line. If we want to find the bottom line, we have to go to the bottom. Okay, so these are the these tell you how good each forecast is for each period, but overall, how good are the forecasts? Okay, so we need to go to the bottom. So I click somewhere here, hold down Control and down arrow. Okay, so now we're at the bottom. I'll scroll down a little bit. I'm gonna, excuse me, I'm gonna pull aside this, if I can, yes, pull aside the graph here. I'm just gonna delete this because It's not helping me in any way. So what I have here is, so control up arrow, so this is the error, okay? I want the average of these errors, okay? So control down arrow, I'm going to say equals average, open parenthesis, up arrow, okay? Hold down shift and control, up arrow, and then hold down shift and press down arrow once, and then okay. So what this shows me is I'm taking the average of these cells. So the cells in with the blue border are included in this average. So I have averaged the errors. Okay, enter. So on average, my error is 704. So my forecasts are 704 passengers about the actual on average. Okay, so I have an over forecasting bias. No, it's the other way around, because I'm taking actual number minus forecast, and so I'm underestimating. The forecast error is positive, I'm underestimating. Okay, so I click here and drag to the right. Okay, now what this means is that this formula is transferred here, here, and here. Okay, so what does that mean? This is the mean forecast error, MFE, mean forecast error. So this is the average of the positive and negative forecast errors. And it says, on average, I'm so many passengers below the actual passenger numbers. Now, this is the average of absolute forecasts. Okay, I click here, the blue lining, you see, goes all the way up to here. So what does this tell me? On average, I'm off by 9,000 passengers. Either way, I'm off either above the actual or below the actual, but I'm off usually on average by 9,267 passengers. Okay, and here this is the mean of squared errors. Okay, these squared errors, and this one is the average of mean of absolute percentage errors. So if I scroll up, absolute percentage errors. Okay, now it looks like 0, but it's not, because we haven't formatted it as a percentage. So to format it as a percentage, I click here, I click the format painter, and then I click on 0. Okay, here we go. It says on average I'm off by about 15%, positive or negative in either direction. Okay, so this is mean squared error. This is mean this is mean absolute deviation, mean squared error. This mean absolute percentage error. Okay, so mean forecast error, mean absolute deviation, mean squared error, and mean absolute percentage error. Okay, so you need to put these in a table in your report. Okay, so these are calculated for the exponential smoothing forecasts. Okay, now let's calculate the same things for the regression forecasts and see if they're any better or worse. Okay, so how can I do that? Well, I just simply copy. Okay, I can write the formulas and everything here, but I don't have to, so I'll just copy. Okay, and I'll come up here and 1, 2, 3, 4. You should copy it here, paste. Okay, so this is mean forecast error for the regression forecast. You see the blue lining has selected all these errors. Escape. This is mean absolute deviation. Yes, it has the right cells selected, mean squared error, etc. Now, mean forecast error is 0. Okay, this is always going to be true because the regression line is calculated to make this 0. Okay, the regression line is not any line. The regression line is a specific line, and it is the one line that makes mean forecast errors 0. Okay, so on average, what this tells me is that on average I'm over forecasting and under forecasting. 50% of the time I'm over forecasting, 50% of the time I'm under forecasting. Okay. In terms of mean absolute deviation, okay, I'm off by about 10,000 passengers with the regression forecast and only 9,000 passengers with exponential smoothing forecast. So the smoothing forecast is better in terms of mean absolute deviation. Similarly, mean squared error is higher here. I want this as low as possible. MAPE about 15% here, about 17% here. Lower is better. Okay, so now I have a quantitative numerical way to compare two forecasts. Okay, and this is the graphical illustration. Blue line, the actual passenger numbers. Red line, exponential smoothing forecasts. Okay, and the green line, straight line, is the regression forecast.